Okay, good morning students. So before class we have discussed about slab based plate in design column foundations. Now it comes gusset base plate. So it is similar to the slab base plate only. It is similar to the slab base plate only. But when the column foundation is designed where the column is loaded with axial load with greater load, okay, with greater load or with more load, gusset base is provided. Okay, when column has more axial load, when column has acted more axial load, then gusset base plate is provided. So it is also same as slab base plate only, design procedure also same, but here we have so many checks. Why? Because axial load is falling on the column, so the column may be buckled. So the column will be buckled. The column will be buckled. So already you have know the buckling procedure in SM. In SM. Okay, strength of materials. So here the design procedure for gusset base plate is. Here the design procedure for gusset base plate is. So first one is similar to slab base plate only. First step, how to calculate the bearing strength of concrete. How to calculate the bearing strength of concrete. 0.45 FCK. 0.45 FCK. So FCK is nothing but compression strength of concrete. So it is comes on grade of concrete. Okay. Second step, area of base plate. Same similar area of base plate, that is PU by 0.45 FCK. So PU is nothing but factor load, not axial load. PU is factor load. Okay. Next, here comes the size of base plate. So here you should have so width and length. Width and length. So width is nothing but width of flange plus 2 into thickness of gusset plate. So width of flange plus 2 into thickness of TG is nothing but thickness of gusset plate. Thickness. Okay. So thickness of gusset plate. Say length L is equal to DF, depth of flange, plus 2 into thickness of gusset plate. So here comes width and length of gusset. So slab base plate. Okay. So next step, here it is the main step. Check for buckling. Check for buckling. So already told what is buckling is nothing but, so the way the axial load is acted on column, the column tends to buckle. The column tends to buckle. That is nothing but where the axial load falls on column, the column tends to bend. Okay. Here for beam means we will call as bending moment. For column is nothing but it will buckle. It will buckle. So here check for buckling. We taken this as a slab base plate. So pressure on gusset. This is the pressure acting on gusset base plate. So this is the column. So this is the S0 and this is the D and this is the length. Okay. So this is the S0 is nothing but outstand flange. Outstand flange. Okay. D is nothing but depth. So we have the formula. D is 29.3 epsilon TG. Here epsilon is nothing but 250 by F5. TG is nothing but thickness of gusset plate, which we are provided. So the checks must be satisfied this both. The checks must be satisfied that both D and S0 should be less than or equal to 29.3 and 39.6. So while telling the problem, these formulas were in code book. I will say the page number. Okay. So this is the fourth step. So this is the check for buckling. So fifth one, same intensity pressure. Intensity pressure means load by A1. A1 is nothing but area provided. So here area means base plate. So here area, we have provided the size now. So from the size we will get the area provided and calculate the intensity pressure. Next, bending moment. So already said the column is acted with axial, more axial load. So gusset plate is provided. So we will get the bending moment at some critical section. Some critical section where the buckling will fail. So in the critical section, the formula is M is equal to W C1 square by 2. So W C1 square by 2. So this is the formula which we have known. So W C1 square by 2, where C1 is nothing but cantilever projection. Where C1 is nothing but cantilever projection. Okay. So here design bending strength. Design bending strength MD is equal to 1.2 Fi gamma n ZE. 1.2 Fi gamma m naught ZE. So Z is nothing but section modulus. Section modulus. We have known Z is equal to I by Y. So here comes the formula BD square by 6. So here B 1 meter, D T. So 1 into T square by 6. We will get 1 into T square by 6. We will get T square by 6. I have substituted here 1.2 Fi gamma m naught into ZD T square by 6. T square by 6. Okay. So from the equilibrium equations, we will know bending moment which is equal to bending strength. M is equal to MD. So I have substituted M value WC1 square by 2 is equal to 1.2 Fi gamma m naught T square by 6. Here gamma m naught is 1.1. By substituting gamma m naught 1.1, by solving we will get the value of T is equal to C1 root 2.75 W by Fi. So C1 we know, W we know, Fi we know. So we will get the thickness. So this is the step. So here we have 3 steps of. So what is the first step means? Connect of column plane with gusset plate. So this is the column plane. This is the gusset plate. So we will connect the here. And next step, gusset plate with base plate. Gusset plate with base plate. So both by welding. Both by welding only we will connect. And last, if in case they will ask provide bolts or rivet, so we will provide bolts with some diameter, with some numbers and with some diameter. So this is the gusset plate design procedure. So first step is a gusset plate means what is the gusset base plate? So where the column acts accelerated, more accelerated than slab base, more accelerated. We will take the column foundation as gusset base plate and we will design the problem. So first step bearing strength same. Next area of base plate. Next size. Next check for buckling. Next intensity pressure. Next bending moment at critical section. Next design bending strength. From the equilibrium equations of design bending moment and design bending strength, we will calculate the thickness T is equal to C1 root 2.75 W by Fi. So here connection of column flanges with gusset plate, collection of gusset plate with base plate, and providing some bolts or rivets with some mm of dia. So this is the design of gusset plate. So please follow the video and write the procedure in your notes as I kept the PDF in your group. Okay, thank you.